So, example 9, we got our new parent function, the square root of x, and our new function, cube root of x. You should know what they look like. On number 9, we have our cubic function, which let's just sketch it real quickly here. We should be able to sketch this pretty quickly. Um, I'm not going to even draw anything out. Let's just see if we can remember this over the weekend. X cubed is the one that has the domain and range of all real numbers, right? I better draw the parent function at least. If we look at the cube root of x, that's the one that comes in from the bottom curving upward, goes vertical, and then leaves going out. That's the parent function. What would the negative do to that graph? Reflected across the x-axis, so now it's decreasing. And where is the vertex? Where is the point of symmetry or the inflection point? Where did it go to? -2, -6, right? -2, -6. So now all I got to do to draw the graph is draw it decreasing to that point and then decreasing beyond that point. So there's a new function. That's all we had to do. Now here's what the question is asking us. Find the average rate of change from -10, let's call this -10 right here, to -1, which would be right around here. Okay? So what I need to do is figure out, on average, how fast do I get from here to here? If you remember average rate of change, it's all about finding the slope of that line. We call that line the secant line. I'm going to throw that term at you. The secant line. It touches the graph in 2 points. The graph is curved, right? But it touches the graph in 2 points. So once you know it's the slope of that line, what do we need for slope? Didn't we learn that in Algebra 1? Slope is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Yeah? So let's just see if we can find the ordered pairs. I know that's -10 comma something, and I know that that's -1 comma something. I just need to find the y values that go along with it so I get the ordered pairs. So let's come over here where we have room, and we'll find them one at a time. Let's figure out what f of -10 is. If I plug in a -10 to f of x for x, I get negative cube root of -10 plus 2 minus 6. All right, now I just got to simplify. So we simplify on the inside. -10 plus 2 is, thank you. There you go. That was easy. You get -8. Yeah, good. Minus 6. Now we talked about this the other day. What's the cube root of -8? -2. So that gives me -2. There's still a negative out front. Oops. And that's still minus 6. And of course, what's -2 also known as? +2. So we get 2 minus 6, which gives us it's -4. Now notice my graph. Let's talk about the difference between my graph and the actual. That is supposed to be -4. Does my graph look like it's at -4? No, my graph looks like it's supposed to be positive something. The reason that we're off is because, remember, what the graph is actually looking like, if I draw it here in silver, it's actually looking like this. It comes in a lot more flat, and then at the last minute it turns down, and then at the last minute it turns like that. That's what the actual graph looks like. Okay? I just don't like drawing it like that because I don't get to see the curve. So you trust the math, not the graph. The graph is just a quick sketch. All right? So I have my first ordered pair, -10, comma -4. The math doesn't lie. Your graph might, though. All right, I got to do one more. I got to do f of -1. I'm glad I found the y value. F of -1. I do it the exact same way. I plug a -1 in for x, and now I get negative cube root of -1 plus 2 minus 6. And then we simplify. Your number should come out to be somewhat nice. What's 2 minus 1? 2 minus 1 is -1? Should be +1, right? And what's the cube root of +1? 1. So I get -1 minus 6, which is -7. So the other point is -1 comma -7. All right, now I'm almost there. What do I do once I have my 2 points? I just need to find the what of those 2 points. What's another name for average rate of change? Slope, baby. Slope. It's just the slope. So let's go ahead and do it right here. I'm going to call it m, the slope. It's just the change in the y over the change in the x. Does it matter which point we start with? If we're consistent, no. I'm going to start with the one on the. I'll start with the one on the on. I'll start with the negative 10, negative 4. So I'll use its y value negative 4 minus the other y value of negative 7 all over the change in the corresponding x values, which is negative 10 minus negative 1. Change in the y, negative 4 minus negative 7, over change in the x, negative 10 minus negative 1. This problem's not hard, but it's very tedious, right? There's a lot of negatives floating around that we need to be very mindful of. In fact, let's simplify this. This is now negative 4 plus 7 all over negative 10 plus 1, which gives us 7 minus 4, which is 3, all over negative 10 plus 1, which is negative 9. And what does 3 negative 9 simplify to? What kind of 1/3? Negative 1/3, yeah. And the negative could be in the top or the bottom or out front. There it is. There's your answer. Negative 1/3. That's the average rate of change. Okay? All right. Sketches and graphs can be misleading, but the math doesn't lie. That's why we like to compute things, because it gives us the real picture. And sometimes, like what I misled y'all to believe, it's actually positive already at negative 10. It's not. It's a lot flatter than that. So it stays negative. So what we actually found is this. If you want to use my silver graph, we actually found the slope of this purple line instead of the black line. And is that a reasonable slope? That should be a negative slope, right? Down and right, down and right. Yeah. So to get from this point here to the other point, you can either follow the curve, or you could simply go down 1, right 3, down 1, right 3, down 1, right 3, down 1, right 3 at the same speed and get there at the same time. This basically has the seeds of what calculus is about, the first semester of calculus, if you're interested. We talk about rates of changes at times, not on intervals. Okay, so let's review what we did there. It was kind of a lot. Did we really need to draw the graph in order to answer this question? Was it absolutely required? No. What we needed, though, was the y values at the two x values, and then we just did change in y values over the change in the corresponding x values. Got it? You don't have to sketch the graph. All right, any questions on number 9? All right, describe what the steps you would take to graph AH and K if you were given the values of AH and K in this function. Okay, so what would you do? What would be the first thing you would do if you were to sketch this graph? Would you look to see what the parent function is? What's the parent function, cube root or square root? Square root. So if you're thinking about the parent function, I'll draw it in purple. That's the one that comes out of the origin and just does that. It doesn't live in quadrant 3. All right. Now that you know A, H, and K, what would be the first thing you do? I would say describe. So first, I'm going to identify the parent function. This is my description, comma. Then, what would we do next? Would you look at H and K, or would you look at A? How about, let's look at A. What if A were positive, would we really concerned what the number was, like stretching or compressing it? Do we ever do that? What's the most important thing about A that we're concerned with? If it's a reflection, whether it's positive or negative, then I would see if A is negative and if an x-axis reflection was necessary. Finally, once we know the shape, once you know if there's a reflection or not, you know what the shape looks like. It's either going to open up and to the right or down and to the right at some steepness. Then all you have to do is look at H and K, which is your vertex, move it to where it's supposed to be, and draw your final shape from there, right? So finally, put the vertex at the point HK, then draw the correct shape from that point. That should pretty much be it, don't you think? Yeah. And we've done that already with actual numbers, so we know how to do it. All right, that's it. So the average rate of change was a little bit tedious, a little bit cumbersome, but it worked out to values that actually worked pretty nicely. All right, we're done with this section. Any comments or questions on it? All right, so you have the rest of the period to finish 11.2 homework, which is due on Tuesday at 9 a.m. And then quiz 11.1 to 11.2 on Tuesday. Okay. All right. Some of y'all have asked questions. I can answer those now that we're done. All right. Have a good, productive day.